Hi. So in this section, we are going to learn about the formulas that are related to the trigonometric functions. So as we know that, we will learn the formulas that are related to the trigonometric functions now. So you know about trigonometric functions, right? So trigonometric functions. So first function is sine theta. Whenever you have this 90-degree figure, for example, this is our ABC triangle. Okay, so this is our theta angle. Okay, so when we have this is a theta, so opposite to the 90-degree is hypotenuse. So this is our base, so this is the opposite. Okay, opposite side. So sine theta is equal to, we have opposite. Okay, ये थीटा के सामने जो होता है अपोजिट. ओके, अपोजिट टू दिस थीटा इज AB. Okay, so sin theta is equal to opposite by hypotenuse. Opposite by hypotenuse. Opposite by, we can write hypotenuse. And next formula is, okay, so we have cos theta. Cos theta is equal to, we have base by hypotenuse. And we have tan theta is equal to opposite by base. And fourth, cosec theta is equal to, we have hypotenuse by opposite side. Okay, and we have sec theta is equal to hypotenuse by base. And similarly we have, okay, cot theta is equal to base by, okay, we can have base by opposite one. So what you can observe here is that so every formula, this theta angle, we are measuring with the help of any two sides. Sometimes we use opposite by hypotenuse, sometimes we use base by hypotenuse, sometimes we used opposite by base, so sometimes hypotenuse by opposite. We named this with one of the function sine theta is equal to opposite by hypotenuse. It means sine theta, I have to practice it, this opposite by hypotenuse. Okay, theta is opposite to the theta is opposite side, so we have hypotenuse which is opposite to the 90-degree. Okay, like that we can practice it very well, so then we can understand it very well. Okay, so this is about the trigonometric functions. Now we will try to learn about the trigonometric ratios that can be possible with the help of these things. Okay, see, now trigonometric ratios that can be possible here is, okay, trigonometric ratios. Now what you can observe here in the last formula is that sine theta formula is opposite by hypotenuse, but cosec theta formula is hypotenuse by opposite. So I will multiply here sine theta into cosec theta, so I will get the value 1. So this is called as reciprocal relationships. Okay, this is called as reciprocal relationships. Okay, so this is called reciprocal relationships. Now next formula is, okay, we have this, you can observe cos theta and sec theta, these are reverse to each other. Okay, therefore these are reciprocal relationships. Okay, so cos theta into sec theta is equal to how much? 1 we have. Third formula is tan theta into cot theta is equal to 1 we have. Okay, like that you can have these formulas. Now if I take any one formula, if I want the formula for sine theta, so I can write sine theta is equal to 1 by, so this cosec theta I will send to the other side, so it will become 1 by cosec theta. Okay, and in the similar manner, so I can have cosec theta is equal to 1 by sin theta. Okay, so this is I wrote from the equation 1 itself. So this first trigonometric inverse properties. Okay, so this is about the trigonometry ratios. Now we will learn about the square identities in trigonometric functions. So before going to the square identities, we will also learn about the allied angles formulas. The allied angles formulas that we are going to use here is, always you need to remember this. Okay, so whenever we have these coordinate systems, okay, so when we move it in this manner, okay, when we are moving in this manner, okay, anti-clockwise direction, then what you can have is that this is 360 degrees. So this is 0 degree, this is 90 degree, so this is 180 degrees, so this is 270 degrees, or up to 360 degrees we can have. Okay, so when we have this type of things, so we can have here all trigonometric function are positive. Okay, whenever we have up to 90 degree, so trigonometric function will change. Sin theta will change to cos theta. Okay, cos theta will change to sin theta. Sec theta will change to cosec theta. Tan theta will change to cot theta. Okay, like that. So now how we can use this one is that, okay, for example, we have this sine of 90 degree minus theta. We can have cos theta. Okay, and cos of 90 degree minus theta, we can have sin theta. Okay, tan of 90 degree minus theta, we can have cot theta. So like that we can make many formulas by using this allied angle things. Means every value we are writing 90 degree minus theta. Okay, 90 degree minus theta means it is under the first quadrant only, 0 to 90 degree. Okay, that is first quadrant only. So we will use it as a allied angle formulas. So next we will learn about the square identities in trigonometric functions. Okay, square identities in trigonometric functions. So now when we have these square identities in trigonometric functions, so I will show you what are the square identities in trigonometric functions. Okay, we are going to learn about square identities in trigonometric functions. Okay, in trigonometric functions. So you know about square identities, right? So you learnt in the basic classes. Okay, a plus b whole square is equal to a square plus b square plus 2ab. These are the square identities in algebra. These are the square identities in algebra, but we want a square identities in trigonometric functions. So I will write the first square identity that can be possible is sin square theta plus cos square theta is equal to 1. Okay. Okay, so if you want to prove this, take the LHS. LHS is given sin square theta plus cos square theta. Okay, sin square theta plus cos square theta. So what is the value of sin square theta? So you know that it is opposite by hypotenuse. So I will write the value of opposite by hypotenuse sin theta. Okay, I squared it. And cos theta value is base by hypotenuse. Base by hypotenuse. So I will again square it. Okay, so now distributing this square to the both numerator as well as denominator. So now it will become opposite square divided by hypotenuse square plus base square plus hypotenuse square. So now hypotenuse square is same in the denominators of both the terms, so we will take it as under one bracket hypotenuse square. Okay, so we will write opposite square plus base square. So we know that opposite square plus base square is equal to hypotenuse square according to Pythagoras theorem. Okay, so this is equal to how much? a hypotenuse square. According to Pythagoras theorem, I wrote this. Okay, hypotenuse square divided by hypotenuse square. So these will cancel, it will be equal to 1. Okay, it means I got the RHS as 1. It means my identity is true. Sin square theta plus cos square theta is equal to 1. From this identity, I can make as many as possible identities. If I want sin theta formula, so what I can do is that, so I will take the identity first. Sin square theta plus cos square theta is equal to 1. So if I send this cos square theta to other side, it will become sin square theta is equal to 1 minus cos square theta. So then send this square term to the other side, so it will become sin theta is equal to under root of 1 minus cos square theta. Okay, like that we can make the identities. Similarly, we have cos theta is equal to under root of 1 minus sin square theta. You can try this yourself. Similarly, we have two more identities. 1 plus tan square theta is equal to, we have sec square theta, and 1 plus cot square theta is equal to cosec square theta. So these are the two more identities you can have. So these are trigonometric identities, you can say. Okay, so now hope you have understood these things so very well. So I hope that these all things are clear. So we can also learn about the values, okay, values of trigonometric functions and all these things in the coming video. So hope you enjoyed this video very well. So thanks for watching this video.